Hi, I'm Colin. In this module, we're going to revise the concept of a composite function before showing you how to differentiate a particular composite function, y equals the sine of x squared plus 1, using the chain rule. Now, consider the function y is equal to sine of the quadratic x squared plus 1. Now, since x squared plus 1 is a function in its own right that has been thrown into the function that sines everything, we thus have a function inside of another function. Or what's commonly called a composite function. To show this more rigorously, let me define f of x to be the standard sine function, sine of x. And let me define g of x to be the quadratic x squared plus 1. Then the sine of x squared plus 1 is therefore just the sine of the function g of x. That is, the entire function g has been thrown into the sine function as an input. And since the sine function is the function f, we're therefore just throwing the function g into the function f. This here precisely shows that our original function is just one function inputted into another, specifically the function g inputted into the function f. To summarize, two functions, f and g, can be combined together to create a brand new and more complicated function using a special operation called composition, which is denoted by an open circle between f and g. This new function, called a composite function, or more specifically, the function f composed with g, is defined to be the function you get by throwing the function g into the function f as an input. With regards to terminology, the function g that's stuck inside is called the inside function. And the function on the outside is called the outside function. Let's now learn how to differentiate composite functions. This is done using something called the chain rule. To be able to use the chain rule, it turns out that it's crucial that you're able to correctly identify the inside function of a composite function. Let's employ the procedure on the composite function sine of x squared plus 1 and show that its derivative is the function 2x times cosine of x squared plus 1. That is, for any x value, the function 2x times cosine of x squared plus 1 outputs the slope of the tangent line to the original function at that point, thereby telling you the rate of change of the original function at that point. Alright, to begin, the first thing to always do is to identify that the given function is indeed a composite function. That is, the composition of two functions. This is in contrast to, for instance, the product of two functions. Which is a different type of function that requires a different method called the product rule to differentiate. Can you tell the difference between these two functions? It is quite common for students to mix up composite functions with product functions, so please be careful. Now, once you have established that the function is indeed a composite function, you need to immediately identify the inside function and call this inside function u. We can then write y as a function of u. Since y is the sine of x squared plus 1, and we've just called this quadratic u, y can therefore just be written as the sine of u. We then invoke the chain rule for differentiating composite functions. This states that the derivative we seek, which is the derivative of y with respect to the variable x, is just the product of two smaller derivatives, dy du and du dx. So all we have to do is to work out these two smaller derivatives, multiply them together, and then we're pretty much done. One easy way to remember the chain rule is to pretend that the two smaller derivatives are fractions. That means these du's can cancel, which means dy over dx is equal to dy over dx. Alright, let's first work out dy du. This means we need y as a function of u. Here it is. Thus, differentiating sine u with respect to u, we get cosine of u. Now let's work out du dx. This means we need u as a function of x. Here it is. Thus, differentiating x squared plus 1 with respect to x, we get 2x. The chain rule tells us that the derivative we want, dy dx, is just these two smaller derivatives multiplied together. Which is therefore just 2x times cosine of u. And since we're differentiating with respect to x, our final answer must only contain the variable x. Thus, we should convert this u here back to a function of x by using our original substitution. U equals x squared plus 1. This gives us a final answer of 2x times cosine of x squared plus 1, as required. Alright, I hope you found that useful. See you next time.